Hi again. Welcome to Lesson 4 in our parabola unit. Today we're going to convert the quadratic equation from vertex form to standard form. So notice y equals quantity x plus 5 squared minus 3 is in vertex form. We are going to expand, then combine, then write it in order. So first, let's expand the x plus 5 quantity squared. So that means we're going to x plus 5, and I'll just show you on the side, x plus 5 times x plus 5, and I'll show you all at once. It will turn into y equals x squared plus 10x plus 25, and then don't forget the minus 3 at the end. Now we're going to combine and write it in order. So combine like terms, y equals x squared plus 10x plus 22, and that is now in standard form. So you just went from vertex form to standard form. So let's look at the first example. Example number 1. We're first going to expand. Do not distribute the 2 until after. So first, y equals, leave the 2 out front, expand the x minus 3 quantity squared, x squared minus 6x plus 9, and don't forget to add on the 8. Next, you are going to distribute the 2, y equals 2x squared minus 12x plus 18. Keep that 8 at the end, and now we will combine and write it in order. Highest exponent first. That's what standard form and in order represents. So 2x squared minus 12x, combine the 18 and 8 to get plus 26. Okay. Let's look at one more example before we get into modeling these equations. Okay, so the last one, we again are going to expand, leave the negative 3 out front, x squared plus 8x plus 16 minus 5. Now you want to take the negative 3 and distribute. Negative 3x squared minus 24x minus 48, and don't forget that minus 5 at the end. Now we can combine and write in order. Negative 3x squared is our first term, minus 24x, and then combine minus 53, and that is now in standard form. Okay, so next we are going to do modeling with math, which means word problems. Everyone's favorite, math word problems. Okay, so the following functions are used for the specific situations. Object is dropped. That means if you remember in elementary school when you did an egg drop, those of you who didn't do the egg drop from the top of the roof or out the top of the window, what it means is you're standing at the top of something, could be at the top of a sliding board, and you just put your hand out and drop a ball or whatever the item is that you are dropping. That is the first equation. The second equation is when you throw an object, for example, on a baseball field, softball field, football field, an object goes up and then it comes down. So negative 16 represents the gravity. So let's write in everything else. H will represent the height, and the height is in feet. T will represent the time, and the time will be in seconds. H sub 0 is going to represent the initial height. That would be your starting height. Again, in feet. And then vertical velocity. That's what v sub 0 represents. Vertical velocity. And that will be in feet per second. Okay, so what does vertical velocity mean? Here I will show you some representation. So if v sub 0 is greater than 0, okay, that means something goes up and then it comes down, and the vertical velocity we are talking about is on its way up. Okay? If v sub 0 is less than 0, that would look like this. And for example, again, if something goes up and then comes down, what if you are spiking a ball in volleyball? So when you spike, you're at the top and you're forcing it down. So that's when vertical velocity is less than 0. That's what we represent from sometime here between here and here. Okay, but what if v sub 0 is equal to 0? Okay, that would look like in archery when you are shooting the arrow straight out before it actually drops. That's when v sub 0 will equal 0. Okay, so let's keep those two equations in mind as we set up our equations, starting with example number 1. Jack tosses the ball in the air. The ball leaves his hand 4 feet above the ground and has an initial velocity of 30 feet per second. Jack catches the ball when it falls back to a height of 3 feet. How long was the ball in the air? Okay, so let's start off. This is the one that goes up and then it comes down. So we have h sub t equal to negative 16 t squared, that's the gravity with feet, plus our vertical velocity, 30 t, plus, where does it start? It starts 4 feet above the ground. Okay, when he catches it, the height will be at 3 feet. So 3 is going to represent h sub t. We still keep negative 16t squared plus 30t plus 4. Now, in order to solve, it is a quadratic equation. You need to set it equal to 0. So you need to move the 3 to the other side. So your equation is set to 0. So we have 0 equals negative 16t squared plus 30t, subtract 3, so we have plus 1. Now you can use your quadratic formula, set up your ABCs. We know A is negative 16, B is 30, and C is 1. T, which is your time, will represent, in the quadratic formula, remember opposite of b plus or minus the square root of a whole big problem. 30 squared minus 4 times a times c all over 2a. Okay, so now we need to clean that up. I always do the discriminant on the side. So here we have the square root of 964. And now you can place it into your calculator. Remember, you have to use parentheses. Super important. So we're going to set up t equals negative 30 plus or minus the square root of 964 all over negative 32. Here's what's super important. You have to put your parentheses around your numerator. You will get two answers. First, you put in negative 30 plus then you put in negative 30 minus, and you will get two answers. One of the answers, t, is going to be approximately, after your calculator does it for you, 0.033, and it's negative. The other one, t, will be approximately 1.91 seconds. Now, what you found out, when Jack catches the ball at 3 feet, how long the ball was in the air. Well, the negative answer will not make sense, obviously, so we cannot use it this time. So your final answer will be approximately 1.91 seconds. That's how long the ball was in the air. Okay, example number 2 is a little tricky. You may try that on your own. I will show you example number 3. So we're going to scroll on up here. For the pistachio tree has grown to a height of 28 feet. A nut at the top of the tree falls. When will the nut hit the ground? So this is like your egg drop, where you start h sub t, negative 16t squared, no velocity, so we're just adding 28 in that because it's just a drop. Now this is actually a little easier. When it will hit the ground, well, that's when the height is 0. And then we're going to solve for t. So if we add 16t squared to both sides, instead of using the quadratic formula, you can move the 16t squared to the other side, set it up as such, divide by 16, we'll get t squared equals 28 over 16. You can simplify that or not, your choice. Root both sides. When you root both sides, you will get t is approximately plus or minus 1.32 seconds. Now, obviously, we're not going to use the negative because we cannot use negative time when we're wondering how long before the nut hits the ground. So your actual final answer will be approximately positive 1.32 seconds. Okay, so here you did not need to use the quadratic formula. Okay, the last one, the archer is shooting at targets. The velocity is actually 0, so it's going to look similar to example number 3. The last example, example number 5, you're using the area of a triangle. They'll let you try it on your own, and then you can check PowerSchool for your notes, and you can see if you did it correctly. Good luck.